Hello, I'm Roger Bisbee from the Skill Builder channel, and in this video I'd like to talk to you about important changes to the building regulations. Now, for all those people who thought that the COP26 in Glasgow would achieve nothing except a load of hot air and perhaps a few slap-up banquets of haggis, neeps and tatties, then you can eat your words, because it now seems that a lot of those pledges that they made are now being put into action in the UK, at least in these changes for the building regulations. And for all those people that have been campaigning and protesting for these changes to take place, then you can give yourselves a pat on the back, but actually these changes were well in the pipeline before any of that stuff started. They've been years in the making and people have been looking forward to them. So these changes that are coming in June 2022 are actually just a softening up process. They're an interim, and they're paving the way for more stringent changes which are going to come in 2025 under the banner of the Future Home Standard, which is going to make everything a lot tougher to achieve. Now, the idea of these changes is to bring about a 31% reduction in our carbon emissions for any given home, and it's going to be done on a building by building basis rather than looking at a whole site and just random cherry picking a few properties from that site. Each home will have to comply. 31%, where did they get that figure from? Sounds a little too precise, doesn't it? Reminds me of when I do an estimate and I think, oh no, I can't just say £100, I better say £102.50, just so it looks like I've worked it out. But 31%, 30%, doesn't matter. The ambition is there. So of course these changes are going to put pressure on property developers and builders to comply, and you may go boo-hoo, who cares about that? But of course this will translate into higher prices, more expensive homes, which will put them out of the reach of first-time buyers. Now, I'm not making a judgment about this, I'm just stating a fact. It costs money to bring these changes about. So one slightly academic change here is that instead of just looking at the carbon footprint of a building, they're going to be looking at the primary energy use. And the idea of this is that you may say, well look, I'm buying all my electricity from a green source and I'm using a heat pump, or I'm using this, that and the other, and so it doesn't really matter how much energy I use because it's not harming the environment. So what they want to say is, let's not just look at the carbon, let's look at the actual amount of energy you're using, because obviously we don't want people squandering energy, and if we're going to produce more and more of our energy as a percentage from renewable sources, we've got to share that around a bit. We can't have greedy people just saying, yeah, bring it on, I can use as much as I like. Fill your boots. So in this, we're not just talking about how you heat your building, but how you stop that heat being lost. In other words, the fabric of the building has to be inherently more energy efficient. And to that end, we have the building regulations. Now, the building regulations are divided up into parts, and those parts are named after letters of the alphabet. They decided to do this because they didn't think they'd run out of letters. 26 letters, and they're already getting there. The more regulations, the more letters they use up. So what we're talking about first of all is Part L, and Part L governs the insulation in the building and also the heating of the building. So walls, floors, roofs, all these things will have to be improved. And if you're currently building a 100mm cavity and you're filling it with something like a mineral wool and you think that that's good enough insulation, well, it no longer is. You've either got to increase that, say putting in a 5-inch internal block or something like that, or you've got to increase the cavity size, or you've got to put a thermally insulated plasterboard on the inside of the walls to bring it up to that standard. And when it comes to floors, then that means you're going to increase the amount of insulation that you've got on the floor, which means you've got to go a little bit deeper into the ground. And when it comes to the roof, well, the roof, if you're not living in the roof, is a very easy proposition. You just put in a whacking 450mm of mineral wool, which means there ain't a lot of room for your Christmas decorations up there. 450mm, that's a lot. But of course, if you're living in the roof, if you've got a roof space which is inhabited, maybe a loft conversion, or the house has been built with an attic room, then you've got to either put that insulation on the outside of the roof, which is the preferable thing as a warm roof, or you've got to put it between the rafters, and then you've got to put 50 millimeters of something like a PUR or PIR board on the inside to stop that thermal bridging. So you're going to lose a little bit of space on the inside, or you're going to put it on the outside and raise the height of the roof. And I hope that the planning people will look upon us sympathetically when we say that we have to raise the roof slightly above the existing ridge height when we're doing a loft conversion, because we've got to get all that extra insulation on top of the roof, and that's going to raise the height, isn't it? And when I mentioned the insulated plasterboard, which you may have to use on the inside, you're definitely going to have to use it on all the window reveals, all the door reveals. So that means when you put things in like your roof windows, you've got to line those out with insulated plasterboard. When you put in a door, similarly, the reveals on the door got to be insulated plasterboard. So when it comes to the cavity walls, you've got to put in insulated lintels, and if you don't put insulated lintels in, you've got to make that insulation up elsewhere. And given the fact that you've already maxed out on that insulation, that's going to be difficult. So insulated lintels, such as the ones that we featured in our video on Keystone lintels with their thermal break lintel, is the way to go. They were well ahead of the game with that, because I think we made that video about 3 years ago. And the other very big change is that we've got to look at the performance gap. In other words, it's not enough to just put that insulation in. You've got to prove that it actually works. And how do you prove it works? Well, as you're putting the insulation in, as you're diligently cutting your insulation in between the rafters in the loft or anywhere else, you've got to take photographs of it to prove what a good job you've done. It's no longer acceptable to just slash it in with a handsaw, leave all these little gaps around there, put the plasterboard in, and nobody's any the wiser. They want to actually see that you've done the job properly and that there are no ugly gaps around there. Now, when you think about it, there's one way you can do this, of course. You can use something like gapper tape, which you put around the edge, and a nice squashy little foam gasket, if you like, that goes all the way around the edge of each sheet of insulation, and you push that in. We've got a video on that, and it's a great idea, but it is expensive and it is time consuming. And it would be better to think that the insulation manufacturers would start to make insulation which is a little bit more squashy, that you could put in, rather like rock wool, which you can just compress, put in, and it just goes back out to fit. That's absolutely fine, but of course you don't get the insulation values in that you get in something like a PUR or PIR board. So it seems that what we really need is a PIR board that is a little bit squashy, that would allow you to push it into the space and then it will expand again. I don't know whether that's possible, but if it's not, the other idea that they ought to look at is made to measure insulation. Instead of having 8x4 sheets that we've got to cut up, which is time consuming and horrible because you get all that dust in you, why can't they make insulation boards 600 millimeters wide, ready cut, and when we're building the roof, we put an insulation board in, we whack the rafter hard up against that, fix it in position, and that way we've got a nice straight edge. Hopefully we've got a straight edge on the rafter as well. Maybe you still need a little bit of foam or something in there just to take care of that, but you get the idea. You can take care of an awful lot of those things, and by the time you put a 25 millimeter board on the underside, then there's really not going to be much air leakage there, is there? You do that, you take photographs of it, you show them to the building inspector, and then somebody probably comes around with a thermal imaging camera and sees, oh no, there's a bit of cold bridging there. There's going to be a mania of cold bridging. They're going to try and eliminate all these little areas of cold bridging. Although I agree with the idea of all this, it is going to be very, very difficult for builders to find the necessary skilled people to put that stuff in, because it used to be the job that you gave to a labourer and you left him up there with a mask and a pair of goggles if he was lucky, and a handsaw and a tape measure, and he just kind of did it, you know. Because we know that the performance gap actually exists in life everywhere. I mean, if you go and buy yourself a new car, you look at the fuel consumption figures that you get on a car, you can never achieve them. Nobody can ever achieve those. So what they're going to do is they're going to bring this out of the laboratory and onto site, and you've got to actually do it in such a way that you achieve those levels of insulation as per the book. Now, I can't help but thinking that the future is probably going to be some kind of spray foam insulation. But in the UK at the moment, building societies hate that stuff, and there are all kinds of problems with it causing rotting roofs and so on. If we're going to use it, we have to find a better way of using it. We have to get the guys in, spray the insulation in, and it has to have some kind of guarantee, because at the moment it's a little bit on the risky side. So I've mentioned that cold bridging is an issue, and of course cold bridging happens around windows, and now they're going to be looking a lot closer at the performance of double glazed windows and even triple glazed windows. And if you've watched Grand Designs and you've seen all those lovely houses with vast expanses of glass, and you've wondered how they managed to do that, given the fact that building regulations say that you shouldn't have any more than 25% of your floor area as glass, and then you see these places where the entire wall is glass. And the way that they get around that at the moment is they say, all right, I'm going to exceed my allowance on the glazed area, but I'm going to beef up the floor, I'm going to put more insulation in the floor, more insulation in the walls, more insulation in the roof, and so on and so on. But of course, if you've already beefed up the insulation in those places, then it's going to be very difficult for you to do more. So you've then got to start looking at those windows and thinking, well, I need to go triple glazed. If I want a bigger window, I've got to prove that it's still energy efficient, and I've got to go triple glazed. So then we come to heating and hot water. It's going to be very difficult to achieve this without some kind of solar PV, because you just won't get the kind of reductions that they're looking for if you don't go down that route. You've got to make your heating system ready to run, what they call heat pump ready, which is that it should run efficiently at just 50 degrees Celsius. Now that's a good idea, because condensing boilers work a lot better at 50 degrees Celsius than they do at 70 degrees Celsius. They're a lot more efficient. So if we can build houses and we can insulate them properly, and we can put in underfloor heating and things like that are quite comfortable to run on 50 degrees Celsius, then I think that's a great idea. What I do object to is the arse about face method that the government's using at the moment, which is to try and push heat pumps and incentivize heat pumps, which will attract the sharks and end up going into all kinds of buildings which just aren't suitable. I made that case, it was misunderstood by a lot of people, but there you go, that's what happens. I said heat pumps are a good idea, but they're not a good idea in a lot of the leaky old buildings that we live in. There isn't actually a requirement to put a heat pump into a new home, even though you make it heat pump ready, and the simple reason for that is that we're not ready. As a country, we don't have enough heat pump installers, we don't have enough heat pumps. The industry would have to gear up dramatically in order to do away with all those gas boilers and put in heat pumps. And then of course you come down to the service and the maintenance, because we're getting emails from people and comments on a regular basis from people who are saying, I had a heat pump, it broke down, and I had to wait for 4 months during the winter to get somebody to fix it. Waiting for a spare part or waiting for an engineer who knew what he was doing was a real problem. And of course, if you want to save money on your fuel bills, just do without your heating for 4 months during the winter, which is what a lot of people with heat pumps had to do. Of course, they ended up using fan heaters and things like that, which are nowhere near as efficient. And of course, if we're going to produce all this electricity to heat our homes, then we're really going to have to ramp up our renewable energy dramatically. We're going to have loads and loads more wind turbines, loads and loads more solar panels. We just won't be able to cope without it. And of course, it's difficult to avoid that idea that we're probably going to have to build a lot more nuclear power stations. Maybe not big ones. Rolls-Royce are talking about putting smaller ones in, dotting them around, which will be cheaper to build and safer. But one way or another, unless we come up with fusion energy in the very near future, I think that nuclear energy is an inevitability. If you look at somewhere like France, for example, it's got cheaper electricity than we have, and heat pumps work perfectly well out there because they got cheap electricity. Doesn't matter so much if the homes aren't that well insulated, but of course they've got loads and loads more nuclear power stations than we have. So next we come to part F of the building regulations, and this is to do with ventilation. Now, I've spoken about ventilation in previous videos and said that I think it's a mistake to have airtight buildings without looking at the ventilation issues. And the government has still not grasped the nettle on this one and gone for mechanical heat recovery ventilation systems. They've just said that we need trickle vents on all the windows, the same tired old thing that they said before. And of course that does rely on the householder opening those trickle vents. So you've got a warmer building, you've got more insulation, you're lowering your fuel bills, and they're saying what you now need to do is open your trickle vents to avoid the humidity building up and the condensation. All very laudable, but realistically, how does that happen? What they're proposing, incredibly, is that when home builders, house builders build a house, that they hand some information to the purchaser explaining the benefits of using the ventilation system in their house to keep themselves more healthy and to keep their house more healthy, to cut down on damp and mould and all the rest of it. If it's anything like the warnings on the cigarette packets, smoking kills, then telling people that they've got to do these things for the good of their health is probably only preaching to the converted. The people who need it most have it least. It will fall on deaf ears with some people. That's inevitable. You know, the people that are looking to save energy and cut down their fuel bills are not going to think about opening windows. They ought to have done is just gone for a proper automatic mechanical ventilation heat recovery system that would take the onus off the owner or occupier of the house and just leave it to a machine. And of course it has been suggested by people, especially after the outbreak of COVID-19, that we ought to start looking at ventilating houses properly anyway and putting in filtration systems which will clear a few of the bugs and some of the pollution. That has still not been embraced by the government. They've shied away from that and they're looking for further evidence that it works. And they're now on part O. O stands for overheating. Not overeating, overheating. And the idea is that our buildings get hot, and if you design them properly, they won't overheat. There are a lot of places, a lot of countries which rely on air conditioning, and we get comments all the time from people who say, you're barking up the wrong tree with your heat pumps. Instead of using air to water, you should be using mini splits, which are basically air to air, little air conditioning units. You've seen them, you go on holiday, you see them everywhere, rattling away. And what they're saying is you can use those. They're great because they blast warm air in the winter and they put cool air in the summer. So they're saying that's the future, but of course it's not the future. The British government is actively trying to discourage people from going down the air conditioning route. We don't generally have air conditioning in our homes, and the government is fearful that if we do start to look at air conditioning and people do start to put these mini splits in, then we're going to lose the battle, because what we'll be doing is, instead of having one energy hungry season, that's the winter, we'll have two. We'll have the summer when we got the aircon on and the winter when we got the heating on, and we will just go backwards. We will be shooting ourselves in the foot. So they're actively trying to discourage the use of any heat pump which has got a cooling capacity in it. The way that the government is looking to do this with Part O is to say that when you build a building, you've got to look at the risk of it overheating. If it's a south-facing building, you've got a large glazed area, then you need to put some kind of sunshade on there to stop the sun beating in during the sort of midday and so on. So it's a simple thing to do at that stage to bring the temperature down in the house, to maybe put blinds in and all kinds of other things so that people can keep their houses cooler without going down the route of air conditioning. So of course what would be better is if we had houses which simply spun round so that we could turn them towards the sun in the winter and away from the sun in the summer. It was done years ago on Thunderbirds, but of course if you're going to increase insulation, you already are insulating against the heat, because insulation is very clever. Keeps the heat in, but it also keeps the heat out. I don't know how it does it, but it does. And for all those lucky people taking possession of a new home, you will have a whole new load of technology to come to terms with. You will have your heat pump, which you're going to have to learn how to operate. Don't keep switching it on and off. Leave the weather compensation to do the job for you. If it comes on at 2 o'clock in the morning, that's because it knows it's got to come on at 2 o'clock in the morning. Do not, as a human being, try and override the machine. That way lies disaster. And while we're at it, read that leaflet, and if that doesn't work, we're going to have public service announcements on the television telling us, open your windows, breathe, move around, stand up, take more exercise, eat less sugar, eat less fat, keep an eye on your neighbour and report any suspicious activity. And as a responsible dad, when I go around to my kids' houses, I will be checking their radiators to check that they are operating at 50 degrees Celsius or below. And I will also be checking the trickle vents to see that they are opening. because one thing dads know is you can't trust kids to do these things. And on the subject of plumbing and heating, there is one slightly baffling measure that they are suggesting that we adopt, and that is to insulate pipework in voids. Now, I understand this in terms of voids which are in unheated areas where the losses from the pipes don't serve any useful purpose, but what they're actually talking about is pipework travelling through floors. So if that's central heating pipe or domestic hot water pipe, I can understand, but if we're talking about pipework travelling through floors, I can't see why that heat is doing any harm at all, because it's got to escape from there up into the room above and maybe a little bit down into the room below, but it really isn't going to do that much harm, is it? They're even talking about pipework that is running behind dot and dab. So if you've got pipework running down to a radiator, now don't forget, now we're running a 50 degrees Celsius system, we need larger pipework to those radiators. That 10mm pipework won't do it. We need to go up to 15mm pipework that you're trying to shove behind dot and dab, and then they want you to insulate as well. Well, is that going to happen? And you've got to take photographs of it all. So when you're running your pipework, lads, don't forget, photograph it all, show the insulation, then put the floorboards down. It's going to be a completely different game of soldiers. There will be people watching this who will be saying, thank God I'm retiring. So if you think there are any other crazy measures that are unworkable within this new Part L and Part F and Part O, then let us know in the comments below. You know, when I see some of these proposals, it makes me wonder whether the people that are drawing them up have ever been on a building site in their life.